Hello and welcome to the Open Source Silicon Stream with me, your host, Matt Venn. Dun, 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 dun. And we are on episode number 17. So I was running this stream by a friend of mine to get some critical feedback. And he said, you need to explain more about what this is and who you are for people who are tuning in for the first time. Hi, Sylvan. Hi, Sam. Sylvan and Sam don't need any intro, but for me, I've been working in this field of open source EDA for maybe 8 or 9 years and been kind of more focused on open source silicon ASIC design tools. I have a couple of courses to learn how to do your own tape outs with open source tools. You can check them out on the Zero to ASIC course. And this stream is about building the community, sharing the latest news, inviting guests on, looking at the kind of stuff that's going on. It's an experiment that I started this year. Hi, Leo. Hi, Rohan. Hi, Samir. Let me know if the audio is okay. And today we've got a special guest joining, Rebel Mike. You might know Rebel Mike from the Tiny Tape Out Discord or the Zero to ASIC Discord. Also known as Mike Bell. And I took a look at his RISC-V CPU that was taped out on Tiny Tape Out 6, I believe it was, on stream number 3 of this stream. So if you're interested, you can go back and take a look at that. And he's going to be on in a little bit to talk about a new Tiny Tape Out competition that we're launching this week. So stay tuned for more info on that. I could see Mike in the waiting room. Hi, Mike. I'm going to do a little news update and then I'll get Mike straight on. And we've got a lot of people saying hi in the chat. Hi, Peter, Ulysses, Michael and Rohan. Thank you. Thanks for the audio feedback. So the news. I was out for a couple of weeks because I went to Swiss Chips, the launch event. And some of you may know that Swiss Chips is the organization that we're working with to add IHP support to Tiny Tape Out. And we've run 2 test shuttles so far. We've got 1 open at the moment that you can join. It's a 130 nanometer process, and they're the factory that I visited to make my clean room tour video. So it's really good to be working with them again. And we did a Tiny Tape Out workshop with 60 people, 60 high schoolers that turned up, and they did a tape out on the IHP shuttle on a Friday. And then I spent the weekend in Zurich, enjoying the mountains and meeting up with some friends. Saw Mikhail Zeptobars and also Alexander Mordvintsev. More about him later. And then on the Monday, there was the Swiss Chips conference. And then I went to free silicon conference that was held at IHP. And there was a really packed schedule. There were 70 talks in just 3 days. And there was also laboratory tours, and I got to film in the clean room again as well. So it's a great trip away, but it was a lot of work. And I'm still waiting for permission to share some of the footage that I took and the photos that I took there, but I'm looking forward to sharing that. Let me share my screen now, and I'll show you a few slides. Share screen. Okay, this moment where I have to be careful to not dox myself. Oh, nearly. So, and then where's my news here? So, Swiss Chips, little update there. And this was my presentation that I did. And so we got, to reiterate, the Swiss Chips shuttle is open. This date is now wrong. Let's just check the current dates. 49 days left on the IHP shuttle. And then we've got the Skywater shuttle via chipfoundry.io, taping out in 63 days. So those are 2 shuttles you can get access to. And if you taped out on previous shuttles that were affected by the eFabless shutdown, then you should already have received your coupon or your refund. But if you haven't, then just email Claire at tinytapeout.com and she'll get you sorted. Then the big news that I announced there was we have started work on supporting for Global Foundries 180 as well. So that will give us 3 different foundries to work with. And that will be nice to have that resilience in the supply chain. And that initial work packages, these first 2 work packages, have been funded by Tilitus. So I want to say a big thanks to Tilitus. And they make this security key, the T key. So if you're interested in open source physical security keys, then check out Tilitus. And I will just want to say thanks again for sponsoring this work and making that possible. Okay. Lab visits. Yeah, I'm really looking forward to sharing the lab visits that I visited. Saw a wafer prober and some very fancy measurement equipment. I got some photos, but I just need to get that cleared with IHP before I can share it. And then I wanted to also give you an update on Alexander Mordvintsev, who I mentioned earlier. I hung out with him on Saturday in the lake in Zurich. And he has recently updated his viewer. So probably some of you have seen this before. This is a design that he taped out on Tiny Tape Out 9. And there's 2 things going on. There's the simulation of the GDS in the background. You can see all the standard cells flickering on and off. And then here you see what is being rastered out on the VGA display. And what he's just done is added 3D to this. So you can now zoom and pan and rotate and explore this design as it's running, which is super, super cool. So if you want to check that out, you can get the link here. I'll just paste it into the comments for you. And it's also linked. I'll just link it here. This document that I'm sharing now is linked in the description of the video, so you can just click on that and come straight through to here. So thanks, Alex. And that's something that we're hoping to have added to our own GitHub pipeline soon. So that will just get, when you submit a design, you'll get something like this that you can explore. And then the other thing is we've added the Tiny Tape Out 7 decap imaging to the chip viewer, and also Tamash has added a couple more layers. So as well as the GDS layer, the microscope layer, now you can also look at the GDS. So you can look at the actual design that is underneath, because it's like, you wouldn't guess that there was an inductor test underneath the fill there, but here we can zoom in and take a better look. See these designs, and then if there's something that is particularly interesting that you want to kind of know more about, you can turn on the project links, and then you can just click on this, and that'll take you through the Tiny Tape Out workshop, and you can see the author and the project description, and you can open it in the GitHub and check out the whole project. So thanks to Explained for doing the chip decap for us, and thanks to Tamash for doing the arranging the imaging for us. And yeah, just also on the topic of the Free Silicon Conference, we've got ORConf is now open for your registration. You can register here. You can also submit a talk here. We've got the preliminary schedule now on the website. It's going to be here in Valencia, in my city. So if you fancy coming and visiting me and getting involved in this conference, then feel free to register for ORConf. Let me just drop a link to that here as well. And the viewer. So you can access that. And also I just want to give Sylvain Minot a shout out. Many of you know him as TNT on the Discord. And it was really cool to hang out with him at the Free Silicon Conference. And he was also able to help me out a lot with the camera work at IHP when we got access to the clean room. And we did some interviews with the guys downstairs. So thanks, Sylvain. It was cool to see you and hang out. All right. So I think we're probably just let me know if there's any questions in the comments on any of that new stuff. Hello, by the way, Diego. Good to see you here. If you've got any questions, Kenneth, good to see you. Sylvain, thumbs up. You're welcome. Sylvain even helped me out with the grading because the camera that we shot on, I think, RAW or log or something. It looks really flat, needs the grades on DaVinci Resolve. Okay, so no questions from anybody. Hi, Victor. So we'll move on then to the main part of today's exciting stream, which is talking with Mike Bell about his RISC-V processor and introducing this latest competition. So, Mike, how's it going? I think you might be muted.
Ah, there we go.
There we go.
Hi, Matt.
You're calling in,
going
from your
going well.
calling it. Oh, look, I need to change the topic here. Should be more organized. Let me just.
Yeah, so I'm calling in from my narrowboat in
yes.
the UK. I'm actually in the Peak District at the moment, and the signal is a little flaky, so hopefully it'll hold out for the call.
I like your blacked out windows.
Yeah, I'd noticed there was loads of light coming in there, so I just pulled the curtain across.
Yeah, good. Well, everything is sounding good at the moment, and the network quality. How do you get on the network from your narrowboat?
It's just on 4G, 5G when I get it. So yeah.
Rohan says hi.
Works all right. Hello.
And George says, do I have a video on floating gate technology? Which I don't. Sorry about that, George. And Jörn says, hi, all back in Denmark. Hi, Jörn. Good to see you at the Free Silicon Conference. So when did you first tape out your TinyQV RISC-V microcontroller, Mike?
Yeah, so TinyQV was the second RISC-V microcontroller I did on Tiny Tape Out. The first one was Nano V, which was super tiny, just 2 tiles on Tiny Tape Out 4, and then TinyQV was 4 tiles and on Tiny Tape Out 6. So yeah, I think I showed off TinyQV on the Tiny Tape Out 6 bring up party. Got it running.
That's true.
Yeah, got it running MicroPython and reading and writing to an SD card and that kind of thing over SPI. So yeah, it was pretty successful. There was one significant hardware bug in the UART implementation, but I was able to work around that with a bit more software on the RP2040 side.
What was the bug?
The bug was that it always read 0. The UART RX. I had a bug in my test script and a bug in the silicon, so it missed the silicon. I managed to miss that one, but I was able to work around it. Basically, the interrupt for the UART receive worked, so from that I was able to then watch the pin as a GPIO, work out what the character received was. Yes.
Cool. Nice workaround.
Yeah.
Yeah, and can you remember the origin of this competition idea? I was racking my brains.
Yeah, so I think it came up on some 0 to ASIC calls, maybe, or in the 0 to ASIC Discord. People were talking about kind of what was a good first project or kind of a useful first Verilog project that would be something that they could kind of point at and say that they they'd done and as like a significant useful thing, and integrating a peripheral with a RISC-V system came up. And then I think after the Tiny Tapeout 6 bring up party, we were thinking that TinyQV had gone pretty well, and I've done some infrastructure, so it's fairly easy to load programs onto it, that kind of thing. So I think the two things kind of came together, and we had this idea that maybe we could have a competition where people could write their own peripherals and integrate them into TinyQV and take advantage of all of that infrastructure.
So we have slowly worked towards that. I'm just looking at this. I didn't actually put a date when I created this document, but you were adding comments to it on the 30th of January. So this has been some time coming. I think we were planning to do this earlier on one of the maybe Tiny Tapeout 10 that got cancelled. So
yeah, I think we originally planned to do it maybe 11, because 10 was about to close, and then I think we were going to do it on 11 was the original plan, but then things were put on ice for a little while. But
so then there was no 11, and now we've got 2 shuttles open, and at the moment so we're kind of discussing this competition and sharing like what is going to be about and how to enter, and have a look at TinyQV and the 2 types of peripheral that you can attach to it. But we don't have anything completely solid in terms of rules or anything like that. But that's going to go up on the Tiny Tapeout website competition page this week. So we're just kind of going to have a look at TinyQV and the peripheral system that Mike has invented, and then get any questions from you all. And then we'll be synthesizing this all into the official entry. But for now, it looks like we're going to tape out on Sky 25A. So that's closing 1st of September. So you've got about 6 weeks to get involved and to make a peripheral and submit it to the competition. And then probably what we'll do is we will also include it on the IHP shuttle, so that there's a cool project there. I've been kind of trying to rack my brains of like what would be a great tagline, and I've kind of come up with something like a crowd-sourced, open-source RISC-V microcontroller. But I don't like using the word source in there twice. So if anyone has any like better idea about a kind of tagline for this thing that we make, I do think it's cool that we're going to build an open source microcontroller that is kind of come from the community, though. So something that kind of encompasses that. Have you got any ideas, Mike?
Yeah, I'm not sure. One thing I've kind of been thinking about is whether this is really a competition or a collaboration. It's kind of maybe halfway between the two.
Yes, yeah. I think we're going to incentivize by giving prizes, and it's also going to be free to enter.
Yeah.
So we'll do the same thing that we did with the VGA, the demo scene, where we'll give you a free tile to enter. You'd still need to pay for a dev kit board if you actually want a physical copy of the microcontroller. But then we'll have some cool prizes to give away as an incentive. Sam is saying get Charles Law in on this one. Sam, what's your idea? That he's a judge, or that he like submits some crazy peripheral? He'd probably be able to build some kind of LoRa transmitter. Looks like we've lost Mike. We've got the spinning wheel of death. So hopefully Mike will come back in a bit. Otherwise, let me try to find... Sylvan's saying, do all of them end up hardened into a single giant RTL block? Yes. So maybe this is his mic. Mike's back again. I'll remove old Mike. Sylvan just asked, do they all the peripherals end up getting hardened into a single giant RTL block?
Yes, that was the idea. So it's going to be Verilog only submissions. I don't know if we want to get into that yet, but I think the idea was that you'd just make a pull request against the TinyQV repo in the end, and just add the Verilog in, and we'll integrate that and check that the tests are working. And if so, we'll accept the pull request. Yeah.
So maybe let's just take a look at TinyQV first. Do you want to share? Should I? Maybe I'll share a screen in case you get dropped off.
Yeah, sorry, I haven't got anything prepared here, and also my connection does seem a bit flaky.
Yeah. So here's TinyQV, and I'm going to share my screen again. This is the one, right?
Yeah, that's right. So yeah, each tape out I've done of TinyQV, there's been a kind of specific repo for the kind of Tiny tape out integration, and then TinyQV is the main repo, which has kind of continued and has all of the main has the CPU, the interface to the flash, and then peripherals that I've done so far, although the peripheral mechanism we're using for the competition is slightly better than the ad hoc things that I've done beforehand. So the peripherals in here won't be used for this version.
Okay. But this kind of top level README is correct, is it?
Yeah, there might be bits and pieces that are slightly out of date, but it should be correct. Yeah.
Yeah. So I dropped the link in the comments. So if you want to take a look and star this repository, and this is on Tiny Tape Out 6, right? So let's just take a look at that here.
So yeah, I guess just a bit more background on TinyQV. It's a 4-bit at a time CPU. So you've probably heard of Serve, which is a serial RISC-V processor. I was kind of thinking about what would be the optimum kind of implementation of a processor for the constraints of Tiny Tape Out. So given that we don't have enough RAM on the chip to provide any caching for the program, so it's reading the program in from flash as it goes, so that it's using the a QSPI interface to read in the instructions, and then that kind of matches up quite well with a quad serial, we call it, core internally. So it takes 8 project clock cycles to execute one instruction, or a simple instruction. More complex instructions take a few more cycles.
Yeah, so this works with we have pinouts here, this the SPI RAM.
It's the QSPI PMod should be, I think it's at the bottom of that page, maybe.
This one.
Yeah.
This
one, it doesn't have that PMod.
Yeah.
Yep.
Okay, yeah. Yeah, there you go. Oh, also Leo was involved in that, and
yeah. Yep.
It's also worth saying that is available here in the Tiny Tape Out store. So I guess that's maybe something we need to consider as well.
Yeah, I think
is including that as because we included the VGA PMod for people who entered the demo scene. So maybe for people who order a dev kit, we'll chuck in a free QSPI PMod for people who entered this competition. Sylvan's used ChatGPT to come up with another tagline: "Built together, open forever, RISC-V inside."
Very nice.
All right, so back to where were we here? Okay, and then what you've done is created this. Should we start with the byte or the full peripheral?
Well, let's start with a byte one. So okay. Yeah, what we've done is created 2 different peripheral templates for people to use. So the byte one is kind of a slightly cut down one that's maybe a bit simpler to use if you haven't done this kind of thing before, and the full one has the kind of full available interface.
Okay. And so to enter the competition, you're going to have to template this repository, this one or the other one. And this one, the idea is it's a single tile design. So already in the info.yaml, it's a 1x1. And there's actually a fair amount of stuff going on. If we take a look at this, the source files here, you want to walk us through what's going on, or should we look at the source?
Yeah, so to give a kind of brief outline of where the idea here was to create something which you could work on as a normal kind of tiny tape out project. So it's a single tiny tape out tile which does the thing. So the thing is being able to interface with your peripheral in a way that kind of is similar to how it would be interfaced with from the RISC-V processor. So we haven't included a RISC-V processor in the template project. We've just got a simple SPI controller, and then the test script will talk to the SPI, and that's using is it Alonso's SPI controller? You looked at that
actually
another stream a little while ago.
Exactly.
Sorry. So yeah, I think you integrated that with your clock and used that. So and it looked kind of a well put together SPI controller or peripheral rather. So I've used that to drive the interface because obviously you've got the address interface as well as all the inputs and outputs. So the total number of inputs and outputs to the block that you'll be working with is more than the number of pins on the that are exposed. So we needed something to kind of interface that to make it work. So yeah, that's the SPI controller, and from your test script, using the SPI controller to drive your peripheral block, which is what you'll actually kind of put your design inside, is hidden inside functions that will, when it's integrated into the TinyQV repo, will be replaced with test functions which drive RISC-V instructions to interact with your peripherals from TinyQV.
So the interface between the RISC-V core and the peripherals is SPI?
No, it's kind of a data bus similar to Wishbone or that kind of thing. So you've got in this case a byte interface, and it tells you when tells you the address and the byte of data, and you can say I've got a byte of data to come out. So the SPI is just allowing that to be driven externally. So what you could do if you liked is tape out this design completely independently and use the SPI to interact with it. And that allows us to use all of the standard tiny tape out infrastructure. And what we're going to do, if you want to include it in TinyQV,
so then you could just use the RP2040 to run your peripheral.
Sure. Yeah.
Okay.
And then we can take just the peripheral bit and leave all the SPI behind, and then plug that into TinyQV. So I've kind of created two interfaces to the same thing, and the user's going to write that block.
Okay, so maybe if we take a look at, because you've got actually a little test in here, don't you?
Yeah. So if you look at
So this is the interface.
Yeah.
That's the bus interface.
Exactly. So you've got the inputs and outputs to Tiny Tape Out as normal. You don't have access to the bidirectional because that's all taken up by the QSP IP mod. Then you've got the address. So you've got 16 bytes of address space to work with. So you can have 16 byte registers in one of these peripherals. You don't need to use all of that space for something. For even reasonably complicated things, you don't necessarily need that much space, but that's what you've got. Then you've got the data in and this data write flag, which says there is a write pending to you. And then data out. So you should set the data out to match the address that's being provided, and that can be read back by TinyQV.
You said a 16-bit address, but I'm saying this is only a 4-bit input?
Sorry, 16 bytes of space. So it's a 4-bit address. Yeah.
Right. Okay. Sylvan's saying, any reason you didn't go for a standard bus like, say, Wishbone?
I guess this is all a bit homegrown. Possibly it should have a standard bus like Wishbone, but yeah, I guess it's inspired by that. Yeah, the infrastructure here is somewhat homegrown. Maybe we can switch that over. It's kind of similar to what you'd see in a Wishbone bus, I think.
Yeah. Okay. And then here we can see your simple kind of test your test peripheral example where you're just implementing a read-write register.
Yeah.
So absolutely. I would just tear this out and put my own thing in there if I wanted to take part in my competition.
Yes.
And then what happens after I've committed this and I've got my test and I've got my my GitHub Actions working? How do I submit this into the competition?
Yeah, so the idea is you create a pull request against the main tinyqv repo for this, which is at ttsky25a-tinyqv.
And we've just moved this to
yeah, we just moved these over to Tiny Tape Out. Yeah, that's right.
Tell me the name again, sorry.
ttsky25a for that's the shuttle -tinyqv.
Yeah. Great. I'll put this in the notes here as well. So that's actually the right place for it, really.
Yeah.
Okay. So then I make a pull request against this, and then does it have any CI built in at the moment? I guess the normal actions.
So it's got the normal actions. So there's some instructions in the template of what you need to include in your pull request. But basically there's a user peripherals folder under source and test and docs, and you'll put your project into those folders in each of those, and then there's just a little bit of linkage to hook it up, and then that will be included. That should be included automatically in the GitHub action.
Great.
So yeah, here we go.
There. Okay, so we could. If I click this, will it redirect me? Yeah. Okay, cool. We can update.
Yeah, I'll get those links fixed up.
Yeah. Keep your questions coming in, by the way. If you've got any questions, just type them into the chat. Okay, so then what's the difference between the byte peripheral and the full peripheral?
So the full peripheral exposes 32-bit reads and writes, which means that you need to handle whether the full register is being written or just part of it. So there's these flags to say what part of the registers are being written. You get a bit more space, so you get 64 bytes of address space, so 6-bit address, and you get a interrupt line to the CPU. So if you raise that high, then the CPU will interrupt, and you can write an interrupt handler to deal with something happening in your peripheral, the final design.
And then this is limited to a 2-tile maximum size. Yeah,
that's right. And the so the SPI that drives the SPI wrapper that's integrated into this is actually taking up about 20% utilization on that. So you don't have quite all of your 2 tiles. But yeah, stick to that interface and that size, and we'll try not to make the overall project too massive between all of the entries. That's the idea.
and
so it's entirely likely.
Go on.
I was going to say, so I think we'll probably be pushing, well, depending on how many entries we get, we might be pushing the largest project that we've seen on Tiny Tape Out so far, probably a 4x4 or a 5x4, which is the new sizes that are available.
Yes, that's actually something that's worth pointing out is the new TT Sky 25A now supports 4 tile high designs, and the biggest we now support is 4x5, so that's 20, so that's 4 tiles bigger than the previous largest design. Sylvan's got another question. Is there a limit to the number of peripherals?
So at the moment, the limit is 12 of the full peripherals and 16 of the bike peripherals. We can potentially tweak that about a bit, but the wiring's just being generated by the normal open lane, open road flow and routing. There's nothing special there, so probably that might be ambitious depending on how big a peripherals people submit as to what we can fit in one design anyway. So we probably don't want to go much above that.
So let's just say I submit a GPIO peripheral, which is just basically remapping a register to the output pins. That's going to be 5 lines of Verilog. Then that's going to be a very tiny peripheral that's not going to make much of an impact into the overall size. But if I make an AES crypto accelerator that is never going to fit in 2 tiles, but just say I managed to get the 2 tiles, then that would bulk out the overall size quite a lot.
Yeah, absolutely.
Sam has got a question. What is the plan for I/O on the peripherals? Seems like we'll run out of I/O with multiple peripherals.
So each of the outputs, there's a function select which can select one of those peripherals or the generic GPIO controller that's built into TinyQV, or the UART. So one thing that is worth being aware of is it's best not to use the standard UART pins, which I think are out 0 and in 7, or I might have those the wrong way around. It does say that in the comments. So one thing we're hoping to do is to allow people to write tests using MicroPython, and MicroPython communicates over the UART. So if you've used those pins, then it's going to be much more difficult to write tests using MicroPython. You probably want to be using the C SDK. So yeah, you can connect all of those pins, select which peripheral uses them. So potentially, like, different people could select peripherals and have them working together, and but they would obviously need to make sure they're not using overlapping pins. On the input side, all of the peripherals can see all of the inputs all of the time. So there's that doesn't need to be exclusive. They're just exposed to all of the peripherals.
So if I did have like 2 peripherals that both want to be driving an LED on pin 2, what happens then? That's to
so when you set up, so when you launch TinyQV from reset, all of the outputs are controlled by particular peripherals. So I think the UARTs default to the UART blocks can default to controlling those pins, but other than that, it's all set to the GPIO blocks. So at the beginning of your program, you would, before using your peripheral, say, I want this pin connected to my peripheral. So it wouldn't matter if even if a peripheral was just constantly driving an output, it would only matter if they were actually selected.
Okay, so we've got like you know, when I first started with microcontrollers, they were like the PIC chips and the AVR 8-bit tinies and micros. And then when I graduated onto more complex ARM chips and stuff like this, they always had an I/O multiplexer, because you had so many peripherals. You could route them. You might have one or other turned off or move the pins to different places. So we've got a system a little bit like that, where you're only enabling the pins if you want it to be actually running.
Yes. So there's a multiplexer between all of the outputs from all of the peripherals and the outputs. So all of that infrastructure for driving the peripherals and multiplexing them means that instead of the kind of just larger than 4 tile design. The kind of basis of it is around kind of a bit under 8 tiles. So yeah, that's kind of where we're starting from because of all of that infrastructure. That also includes an example plugged into each peripheral, which has an adder and that kind of thing. So as peripherals come in, if they're simple, like you just suggested, that probably actually reduce the size because they're not doing as much work as the examples do that are plugged in. Obviously, if they're bigger, that'll increase the size. So yeah, we'll kind of see how we go there as we're building things out.
And for if people want to take a look at your examples, are they already kind of committed into this into the main one?
Yes. So the examples basically the same as what's in the example in the template.
Okay. Yeah. These two.
But yeah, you can see that in place already.
Okay. So they'll get removed, will they, or are you going to leave them there?
Yeah, so they'll get replaced as we. So when you make a pull request, you'll replace one of the existing kind of dummy example blocks, which are all kind of identical with your peripheral. So they just swap them out. I guess if we are worried about space, we could take some of them away. We'll see how we go, and when we start bumping up space limits, that kind of thing.
Yeah,
we could reduce the number of projects, and which would reduce the size of some of the infrastructure. So yeah, there's balances there.
I think when whenever I'm thinking about an experiment or like a competition or something, I mean, this I guess this is it. Let's call it an experiment. I always try to think about what is going to be, what am I going to consider to be like a successful experiment? And at the top of this Google document, I said getting 20 entries and having a 16-tile tiny QV submitted with lots of cool reusable peripherals, and to grow the tiny QV ecosystem. So, yeah, that's where I'm at. Get 20 entries. Do you think we're going to see 20 people? And do you think we'd even be able to fit 20 peripherals into the space that we have?
Yeah, it really depends on the size. I guess I'm a bit worried that everybody's going to try and do their own like VGA driver, which would be cool.
Oh, we lost Mike. Would be cool, but is going to take up too much space. Well, Mike, here we go. Mike's back. There we go. The VGA driver would be cool, but...
Yeah, I was going to say a VGA driver would be cool, but 16 VGA drivers would probably be quite big. So yeah, nice if people coordinated a little bit on what they're doing. Yeah.
Yeah. So we're going to have a. Well, actually, we're only running one. We've already got a competitions channel at the moment, and actually, people have already started talking about this competition in that channel. Shout out to Cavi. And I think we won't make a new channel. We'll probably just use that channel. So if you've got questions already, you're watching the stream after the fact and you've got some questions, then join the Tiny Tape Out Discord. Let me just throw up a link to that there, tinytapeout.com/Discord, and ask your questions in the competition channel. And yeah, let's try to get 20 entries. And then at least in my books, it will have been a successful experiment. Let's see, we've got a question from Sam saying, can I do analog? And the answer to that is no. It's a good, maybe a good extension. So if this experiment is successful, then we can consider it for next time. Because for doing that, we would probably want to power gate the analog peripherals in case something went wrong with one of them.
Yeah, and we'd need to work out how to have kind of infrastructure in one place and connect down into the analog peripherals, which would give Sylvan a bit more work to work out how that was going to happen as well, I imagine.
We'd have to start thinking about floor planning rather than just bunging all the Verilog together into one big blob. That's definitely the easiest thing. As soon as we've got individual analog designs, they would need to be put in different places. Yeah. So maybe Sylvain, you could tell us how hard you would scream if we wanted to add analog. We'll count the number of H's in the scream, and that will be how bad it is. Ken says, "What does the price structure look like for this?" So we're going to do this like the demo scene competition. So to enter, is going to be free. So you get free area, free tape out. But if you want a physical copy of what did Sylvain say it was? If you want a built together, open forever, RISC-V inside, tiny QV microcontroller, you'd need to buy one of the dev kits, and they're currently running at about $300. So that's the pricing structure, Ken. Sam says, how many entries were there for the demo scene competition? So let me just load that up. This is also leads me on to another question. Let me just share my screen again here. Turn off the comments so I can see the button. There we go. Demo scene competition ASIC. Entries. This is the video, by the way, if you want to check out all the entries. We put them all in one big video. I think it was about 30. Shame these aren't numbered. But yeah, that was that competition went great. Oh, Mike, you've got I forgot you've got your Mandelbrot. Didn't you do one with music as well?
It's based on Pachelbel's canon.
That's it. Yeah,
which was a good way of encoding
this one.
multiple lines of music for no extra cost. Yep.
Yeah, that was a fantastic. That went so well, and we're still waiting on the judging for that because we still don't have the chips. Unfortunately, that was like some of the chips that we lost in the eFabless shutdown. But that does give me one question that is, I guess, will be open to see what anyone in the audience thinks, has an opinion on. I was thinking that instead of waiting for like you said, this is going to be a bit more of a collaboration than a competition, but I do want to have some cool prizes to give away. So we need to have some judges anyway. But I was thinking maybe we do this at the tape out rather than when we get silicon back, so that we can kind of run this loop faster instead of waiting for the chips to come back. What do you think? Is that allowed? Do we have to wait for validated silicon?
It'd be interesting to do that, and maybe it could in a way be fairer, because if there's a problem in the silicon, then that might not be the fault of whoever submitted the peripheral. So I do have.
Have you got a funky FPGA?
Yeah, so this is an FPGA on a tiny tape out board. So I've been using that for testing tiny QV. That's an ECP5 that sits in the standard demo board. So I can use that to check that things are working as we're going along, and start to put together test scripts and make sure that the SDK is developing with that. I want to get to the point that I haven't yet got to the point where I just want a little bit of MicroPython infrastructure to allow people to test their designs more easily. So I'll make sure that that's together and working on that board. So yeah, we could kind of verify people's peripherals on that setup. That board itself is open source, so potentially people could make them. But the ECP5 is a slightly, because it's BGA package, is slightly expensive to manufacture compared to simpler packages, but they're not super expensive.
We are working on an official tiny tape out FPGA breakout board. Pat's working on that. So we'll be posting more info about that later, and that will be available in the shop. So for people who want to test with an FPGA before they get the silicon, that'll be good. Sam is saying, does anyone sell that board? I don't know. Do you want to sell your board, Mike?
I'm not particularly interested in getting into that, no. But I definitely help you. So I got JLC to assemble that. So I'd definitely be happy to talk you through that.
Oh, and Rohan has fabbed Mike's your design already. That's great.
Very cool.
The FPGA. How was the BGA soldering, Rohan? Was it your first time, or are you a seasoned BGA professional? Just answer a couple of other questions here. So, Daybiter, I like your handle, by the way. Daybiter is pretty cool. Maybe an I2C for LCD. That's a good idea. Then you don't need that many pins. But can you do I2C without the bidirectional pins?
Yeah, sadly, you would need external hardware to do I2C because there's no bidirectional pins available because they're all taken up by the QSPI. There were on the Tiny Tape Out 6. There's the SPI interface. I've had that working with an LCD. With SPI LCD. But
so use the SPI instead of I2C.
I would suggest SPI. Yeah, maybe we should have a kind of standard some hardware on the demo board or something to allow you to do I2C. I don't know. That's maybe a bit too specific, or another simple PMOD could allow you to combine some inputs and outputs together.
So you could, maybe that would break out to what's that standard? The Quick standards, Adafruit standard. They have like a kind of little plug-in. Then it could work with all the Adafruit I2C gear. That would be, or is it SparkFun? I can never remember.
Quick or Stemmer, I think is the other one. I'm not sure.
Maybe it could
I'm not
be
sure
both.
whose they are.
They're both I2C standards, aren't they? So you could just have like both sockets on one.
Absolutely.
Board.
They're both exactly the same pinout. They're just different names. So.
Yeah. Okay.
Which is great.
Maybe that would be something a bit like the board that Pat put together for the gaming handset. So there's like a tiny little microcontroller on there that allows like an easy interface to the ASIC, and it could do the same thing but for I2C.
Yeah, that's definitely an option.
Daybiter's asking, no system Verilog allowed. The system Verilog that's supported by the open source tools is allowed, and if that's not enough, you can check out Yosis Slang, which is a plugin that has pretty good system Verilog support. Let me check that. Let me just drop a link to that. Yosis Slang. By the way, just to plug OrConf again, Martin, who's the main guy behind Yosis Slang, is going to be coming to OrConf to present his work on that. But if you want to find out more about it now, I just dropped a link in the comments for you. Rohan says that the BGA soldering was painful. That's my experience as well. I don't know, actually, the ECP5 I didn't find too bad. I also made an ECP5 dev board back in the day. But the wafer level chip scale packages that we got, their first like Google Skywater ASICs were a real pain to solder, I found. John is asking for a link to your board, Mike, so maybe you can drop a link to that in the comments.
I'm trying not to use the internet except on this right now, so I'll drop that either in the Discord or comment afterwards. Yep.
Cool. John is saying, I'd be interested in a group buy. I guess I need a little bit more info. Is that related to the FPGA board, John, or something else? Maybe give a little bit more info about what your question is. Ken says, will the clock have a fixed frequency? That's a good question.
So the kind of suggested, obviously, is a Tiny Tape Out project, so you can drive it at whatever frequency you like from the RP2040. I've always used 64 megahertz with TinyQV up to now, so that will be the kind of suggested frequency. So yeah, if you're going to assume a frequency, 64 megahertz.
Assume
But
64. Yeah, okay, that's good. So just coming back to a question or a suggestion from Javi, I'm thinking about a WS2812 slave peripheral. That's a good idea. I guess you don't mean slave though, you mean master, like to drive the LED, so you could plug in a chain of the LEDs and then drive them. That was actually one of the first things I thought of as well, so maybe we'll do two of them. That was my first ever RISC-V extension project, actually. And there is like, it's the timings of the ones and the zeros. So a classic peripheral could allow you to like set those timings through registers, so it could adapt to different strings. But if you weren't going to do that and hard code it like I did, then you could assume 64, so it works alongside the default frequency. Oh, but Javi did mean a slave, like the RISC-V being driven as if it was an addressable LED. So then you could put like a red, green, and a blue LED on the 3 IOs and then drive it from another. That's a nice idea. Do it.
Yeah, that would be cool.
Yeah, cool. Good idea. With it, and then use the interrupts to be able to handle the data.
Yeah.
Cool. And Sylvan says, depends which ECB5, 0.85 millimeter pitch, okay, 0.5 millimeter pitch are a bit trickier.
I can't remember which one it is, to be honest. I didn't solder it myself. It's beyond my skill set.
Yeah. Oh, so you got like PCBWay or somebody to do that for you?
Yeah, JLC. JLC did that for me. Yep.
Who didn't sponsor this stream, by the way?
No. Yes.
This stream is sponsored by the Zero to ASIC course. Buy now. Okay, so we've got 3 or 4 minutes left if anyone has got any other questions. What was the toughest part about putting this together, Mike? I mean, you'd already done the TinyQV, but coming up with the peripheral and the test scripts and the 2 templates, I mean, it's quite a lot of work, isn't it?
Yeah, I guess it kind of came out of discussions that we were having back in January or whenever it was. So yeah, we kind of hashed that out. I guess the toughest parts are probably all of the infrastructure to plug the peripherals into, which just kind of making sure that all works so that things are passed through correctly. We did a kind of very quick test of this. There was a shuttle that some tiny tape out designs went onto, CAD 25A, I think you were calling it. And we put a version of this onto that, and Yuri very quickly made a design with the help of some LLM, I think. Found a bug in my testing on that design. So that was a good test to have.
Yeah.
We'll keep iterating on that, and it's the way that we've done it. It's nice that people will write tests that can work in one way and then integrate them into the design, and they should work the same. So we'll see whether that throws up any discrepancies, and that will help test that all the infrastructure is good.
Nice. Okay, and I'm just seeing here in our planning document a bunch of different categories. So just to give you a little bit of a flavor, we've got, so this will all be written up again on the competitions page that will be on the Tiny Tape Out website this week. But best documented, best tested, best demo video, most unusual, and community favorite. So those are and then I guess we'll have an independent panel of judges. I have mentioned this to RISC-V International Organization, and they thought it was a cool idea, and one of them might also be on the judging panel and might help to promote the competition. So we'll see how that goes. I apologize, I've been a little bit late in organizing this. Okay, I've got just last couple of questions. John is clarified saying for the FPGA test board by Mike, doing like a group gets or something. I would say probably wait for the one by Pat, because that will be the official one that will be supported and available to purchase in the shop. And Pat's working on that at the moment. Otherwise, what would be your recommendation for something you can buy off the shelf, Mike?
I'd probably go for a Pico Ice. It won't be able to run quite as fast, but it's a UP5K.
Is it kind of that's different from the Icebreaker, is it?
Yeah, so it's the reason that I recommend that is it's got the RP2040 and the Ice 40 chip on the same board. So it's kind of, it doesn't have as many connections as the Tiny Tape Out demo board, but that would that allows you to kind of test it in a similar fashion to on Tiny Tape Out. So yeah.
Let me just drop a link to that.
Been using for a bunch of stuff
here. Anything with the Ice 40 on it will be well supported by the open source tools, and then there's also the Tang Nano, which are very cheap and affordable. And I'm a fan of the 1-bit squared Icebreaker, and like to support 1-bit squared. Good. They're a good company to support. And Jazzy says, how hard is it to design a RISC-V CPU? I don't think it's that difficult. I can recommend Bruno Levi's course. Let me just bring that up and get Mike back on. Here's the RISC-V course that I recommend. And you can also have a look at Mike's Pico RV, Tiny QV, sorry, not Pico RV, Tiny QV core. That has been the foundation.
The Pico RV is probably worth a look as well. Yeah.
Oh, well, the Pico RV is, I would say, pretty old and not very well kind of maintained or supported these days. So, and then there's is it Tiny? There's another one.
Think of?
There's Ulof Serve, and then there's another one. I'm blanking on the name. It's adjustable. It's like can be like 4, 8, 16.
Oh, you think of Phasey RV? Mine are.
That's it, Phasey RV.
One.
Yep.
Yeah, Phasey RV is definitely worth a look as well.
So that's some inspiration, all open source cores you can take a look and learn. And Jazzy always says, want to be a part of Tiny Tape Out? Great. Join this competition. Learn how to make a RISC-V CPU by studying Mike's one, and then create a peripheral for it. That's a great first step. And then the tape out is free if you enter the competition. And then Sylvan's saying Vex, as in, I guess, Vex RISC by Charles Papon. I think that's written in written in Spinal. So that's another option, is to look at some of these designs where they're not in Verilog. They're using another hardware description language. So I think that's a good time to call it a day there. Any last words from you, Mike?
Just looking forward to seeing people submitting some peripherals in and testing this out.
Yeah, so template that repo and get involved. Watch out in the competitions channel of the Discord and on the competitions page of Tiny Tape Out. And let's just give Mike a thumbs up in the comments to say thanks for all of his hard work so far in getting this competition ready for you all. And I also just want to say thanks personally, Mike. Really appreciated seeing this come together, and thanks a lot for all your hard work in making this possible.
Cool, thank you. Yeah, it's been fun.
Yeah, awesome. Okay, thanks for joining, Mike, and see you around.
See you. Thanks, Matt.
Bye. So yes, on to the outro. Just thanks for joining. Send any ideas or stuff that you want to see covered in the future. Let us know what you're interested in. Subscribe to the channel, subscribe to the newsletter, all of that good stuff. Enjoy geeking out over open source silicon. Register for OrConf 2025. Come and visit me in Valencia in September. And have a great week, and I'll see you next week. Take care. Bye-bye.